Yeah, multiply and divides by whatever b is. So by b. Okay? Right on. Variability does what? Yeah, it's the same thing. It multiplies and divides by b. Nicely done. Whatever b is. Okay? All right, very good. As we looked at it, we remembered that the test scores from 1, if you look above, just help me. What was the mean of that? 80, good. And what was the standard deviation? 10, very good. We remembered that. Notice, though, go back with me for just a second. We remembered that this was z-scores, right? Which was the score minus mean divided by standard deviation. We remembered that with a z-score, it standardizes it, right? What does standardize mean again? That's a tough word. Yeah, good. Torrance, it's a z-score. It allows us to have the same level, right? To compare the percentile that I was on my ACT to SAT, it allows me to see where I fell, right? So it's z-scored, it standardizes it. What's the mean of this one? 0. Good, Eric. And what's the standard deviation, Eric? Do you know? You don't know? Does anyone know? Of z-scores. So it's 0 is the mean, and standard deviation is always, by the way, this is always the case, it's always 1. Okay? It's always 1. So it allows me to see how is the data distributed when the mean is 0 and standard deviation is 1. Remember, the reason why it will always be the same is because we're trying to standardize this here. Okay? Standardize. Make it to where it's the same. I can compare two different things. Okay? Questions? We're cool? Tony, say again. Why is it? Why is that the case? Let me see if I can go back and explain it a little bit better. Do you remember over here that when we did this over here, here was the mean, and one standard deviation to the left and right was plus or minus 10, right? When we look at that, that was the shape. Notice the shape is still the same. The only difference now is where's my mean? It's now at 0. Now the only difference is I subtract one standard deviation and add one standard deviation to that in order to make it to where, well, that's what will occur when you standardize and use the formula that you see here. Does that make sense? Okay, cool. It's a great question. Great question. Okay, I think that is it. We're going to go over big ideas real quick, but before I do this with me. Let's see if we just review this, okay? Let's pretend that Coach J took the test scores and he decided to add 5 points to every score, okay? All right, he had to add 5 to each score. But then once he added 5 to each score, he decided that he was going to make this test out of 50, not out of 100. So then afterwards, he divided it by 2. So each score would be added by 5 and divided by 2, each score. If the mean was 80, by the way, this is a good question for tomorrow. If the mean was 80, what would be the new mean if I added 5 to every value and divided it by 2? And why would that be the case? 42.5. Ivana? I had to say your name again because I heard it.
No.
You said 40? Yeah, go ahead. Explain why.
42.5. Because if you add, well, I could be wrong actually, so I don't know. But if you add 5 to each score, then that would make it 85 the mean, and then you divide by 2, then it would be 42.5.
Is she right?
Yes.
Yes, she is. Because the center, Ivana, you're right, because the center changes depending on whether you add or subtract or multiply and divide. You feel that? Yeah. So my new mean would end up being 42.5. All right, here we go on this. Someone different from my left side, help me. What would be the standard deviation? It was 10, right? What's the standard deviation, Tony? Why?
Divided by 2, so I guess the standard deviation would also be by 2.
Good. Why don't I add by 2 or 0.5, 2.5?
It doesn't affect the shape or the spread.
Nice. Nicely done. Nicely done. Do you get that? Are we good on that? Perfect. Okay. Hey, big ideas. We're gonna hit this really, really quick, and then we're gonna fly through. Okay. Big ideas. Here we go. Get this down. We're just gonna get these pieces. Do y'all like the golden nugget piece?
Yeah.
Get excited about it. All right, here we go. Z-score. Emily, what's a Z-score formula again? She's rolling. Yeah, here we are.
Wait. Give me a second.
Okay.
It is number of standard deviations above or below the mean.
Nicely done. It's the amount of standard deviations above or below the mean. All right? Amount of standard deviations above or below the mean. Nice. Someone without looking back, tell me what the formula, raise your hand just so we don't have everyone yelling. What's the formula for Z-score? Claudia.
Value minus mean divided by standard deviation.
Money. Nicely done. So we would say value. You could also say x minus x bar, which is just a gang sign for mean. Okay? Divided by standard deviation. That is my Z-score formula. It's a big deal right there. Okay? I don't think that's on your formula sheet. That's something you'll need to know. The next thing, I think someone even texted me or something and said, Coach, I'm still struggling on this percentile thing. Percentile, the definition for that, just as a review, someone raise their hand, just tell me what that would be.
Oh, it's like the amount of, like, the percentage of stuff that a value is greater than.
Okay? So, the other way. Take that the other way.
Okay, it is the amount of stuff that is less than the
Yeah,
value.
we are. Percent of values less than my value. Hey guys, let's not do that every time. If it's like a big one, then we'll do it. Okay? Just so
Yeah, the ticket for it's pretty big.
All right, here we go. Let's go to the next one. Values that are strictly less than. Okay? And this is kind of the big thing. If we standardize something, someone just tell me how we standardize something. How do we standardize something? 3 tickets. You can tell me. 4 tickets. You can tell me.
Let's just wait for the tickets.
5 tickets.
Track the means of everything? I don't know.
You're pretty close, Ivana. Nicely done. You're close. Subtract the mean. So we got that. But there's something else.
Divided by the standard deviation.
What is that?
Z-score.
Z-score, right? I'm going to get tickets all around. Y'all are rocking. So standardized is change values to Z-score. Right? Because that's really the standardized value. Right? Standardized value. Nicely done. Nicely done. All right, so that's that. I thought I had one other thing. Oh, yeah. So just put right here, if you don't, I think you have this already. When you add and subtract versus multiply and divide, right? Multiply and divide, sorry, shorthand. You know, really, to be honest, for the Golden Nugget page, I'd include this in here. Cool. This is really good. If you go back and kind of look at this, that's what I would include. Or just star that and just say, go and see the let's summarize part that's here. Okay? All right. Rock and roll. How do y'all feel? Y'all feel okay? All right, here's what I'm going to do. I'm going to give you 7 minutes. Maybe less than that, 5 minutes, because we've got to get into 2.2. By the way, 2.2 is not on our quiz, okay? Not on our quiz. But I want to make sure I get one rep in. So about 5 to 7 minutes with someone or a group of you, I want you to do the following, okay? All right, do the following. Now, yes, do the following. Ready? 5 to 7 minutes, go. Y'all have that on your sheet, right?
Oh.
Is that right? Yeah, perfect. But I tried not to. So changing the values I'm changing it to where the values of the text have a meaning in the standard.
say.
How do ACTs compare to SATs, right? Because why? When you have different values, you're comparing SAT and ACT. They're different things. One's out of like 20, right? And one is, you've got huge values, right? Up to 1,600 or whatever. So how do I do that? Well, if I took all of these and I standardize that, that means that both of them now have a mean of 0 and a standard deviation of 1 when I convert them to z-scores. So if I were to plot those at 4 points, again, the shape wouldn't change, right? But the spread of the center would. How would they change to? 0, 1, right? Once I do that, then I'm able to compare what's the shape, center, and spread. I can compare the two. Now we're comparing z-scores. That's where we're heading. Right? Good question.
We know how to do it. We find out. We divide it by it's cents.
Are you gonna have more or less? So if this is the cost, right? In dollars. If I went to cents, would these values be greater or less? Greater, right? So that's why we multiply. You follow me?
Yep. Thank you.
Good question.
Okay, so we're at 70.5.
Noting that $1 is the obligation charge. If you didn't know that,
How you doing, Ryan?
that's why you missed it.
How is this coming for you? Is there anything you're not getting?
Standard deviation.
Oh,
Noting that $1 equals
Good. Let me know, okay?
shape is
If I add it, it changes. If I multiply, it would. This side would go larger than this side. Right?
I look at it.
bigger to above, and bigger one is 5.
Thing that-
The smaller one is 10, right? Not that.
So it says describe the shape, mean, and standard deviation of the distribution. So what I have to start off with, when we convert the cost of rides from like items, we could say that the shape would be the mean would be standard deviation would be we're multiplying by 5. We're adding it to the I'm sorry. In center does change. So what I like to do is I'm pretty sure look at that too. I never was good at that. Like, I'd rather calculate all day. So in order to get it out of the way, just restate what they're doing. And think about what 9 times out of 10, that's really what they're wanting. So when they say describe, if I just say, when we talk about converting cost of rides from dollars to cents, we establish that, and then we go into the others. How we doing, y'all?
I've heard that one.
I did it earlier, but I forgot what it was. Suppose you convert the increased cost from question 2 to z-scores. What would be the shape, mean, and standard deviation of this distribution?
Isn't that you? That's the one where we like multiply by it, add the mean.
So if we subtracted the mean divided by standard deviation, right? Z-scores always have what as the mean?
Oh, 1. No, I lied. Well, that's the standard deviation.
Well, that's the standard deviation. The mean will always be 0. Cool.
Okay, 0. Standard deviation.
1 every time.
1
Do you know why that's the case? If you subtract the mean and divide by standard deviation, it will always produce a mean of 0 and a standard deviation. That's why we're standardizing, because it's always the same. Does that make sense? And the shape would be the same, right? Doesn't the shape never change?
Is this like the case for everything?
Everything. 100%. Because think about it, if I have my values, if I take all my values and subtract the mean, right? And if I standardize every one of those values, right? You're going to have some that are going to be to the left and to the right, but the mean around which your center will be 0, and your standard deviation will always be 1. Good. I'm going to give you about 2 more minutes, okay? 2 more minutes there. Claudia, how's it coming?
Well, I think they're missing a word. How would this be? How is this the shape, the center, the
So when we do standard deviation, or I'm sorry, z-scores, Eric, every time, this is what, it might not look like this, but the standard deviation will always be 1, and my mean will always be 0. Always. Because if you think about it, if I took every value in my data plot, right, and so because we did it, right, we took all of my data right here. We took all my data, subtracted the mean, and then once I got those scores, I divided every one of those scores by my standard deviation. Some will be to the left and to the right, but my center would fall at 0, right? Always. And my standard deviation will always be 1. Why is that? Well, that's why we call it standardizing, because that allows us, when we do that, to be able to see what's the difference between the two.
So,
I'll be right there. Gotcha.
when you're, so it says like describe or explain your answer. So when I'm talking about the shape, like why does it remain the same? I'm saying like the relationship between the word missing, where it's located. But I'm wondering like how.
So the word missing in number 2, we're not sure.
How do you explain why it
Like how why it stays the same.
What do you think?
When you explain it, you could just simply say that when you add or subtract or multiply and divide, like the z-score, you're subtracting the mean and dividing by the standard deviation. And when I add or subtract or multiply or divide, the shape does not change.
So you just it's not just like select. They all change.
So going along those lines is fine. I don't think it has to be as in depth. You can just say, you can just state the rule.
Okay.
It's fine. Good. Sorry, Josh and Jared, what's up?
So,
Is this word compare?
yeah, how would this like the shape, center, variability?
You're supposed to compare the 3.
How would this
Change. Thanks, guys.
Why would be why?
Okay, so right here. This is a double. This represents when it's a double. Whatever the distribution is. If I were to multiply, right? What I do on this side, if I multiply by 100 on this side, it's going to be different than this side. So when it moves, it will move this way. Does that make sense? Yes. Yes. If you multiply by 100. Because it will change, but then also the spread will change too. Whereas if I just added and subtracted 100, right? 25 is part of the, that equally goes from one to the next. Center changes, but my spread will not. Does that make sense? Shape is always the same.
What about like
Shape is always the same. Yvonne?
that mean?
All right, hey, look at this real quick. All right, hey, we're going to get moving here in just a bit, 10:34. All right, perfect. I got to get moving. Real quick, are there any major questions on this? Hey, here's what I would, Tony, you got something? Go ahead.
I would say like will the standard deviation change like question what?
In A?
Yeah.
A?
Yeah.
Would it change? That's a good question. Anybody have that?
Is it
Yeah,
10 or 100?
Correct. It would be multiplied by 100.
Why not 10? Because you square root like 100, right? Because for standard deviation, the formula like you need to square root the number inside, right?
It's true. because the square root of n is on the bottom. But remember at the top when you do x minus my mean, right? And you square that value will be large as well. Does that make sense? Do you follow me, Tony, on that? And so, I hear you, but the top will be just as high as well. So they cancel, giving us just multiply by 100. Great question. Okay, 2.2, I need you to get out those notes real quick. Okay? All right, yes. Okay. Hey, quickly. 2.2a, this is the introduction, okay? As we go into 2.2a, I need you to know a couple of things. There's two types of distributions. A discrete, okay, and continuous. Let me give you the example of that. Discrete would be the amount of free throws I hit out of 10, okay? It's a set number. So like I always say, free throws made out of 10, okay? This is what we'll talk about in chapter 6, okay? That's where we'll go. What we're going to focus on really from now and as we keep going through a lot of this chapter in chapter 2 is this continuous distribution. What that means is that this is more of like a percent inside of this graph, okay? Percent inside of this graph. And later on, like t and chi-squared, some of you have done that before in bio, you'll know that those are kind of where we'll pull from, okay? We'll pull from there. All right, so a couple of things that you need to know. A density curve has a total area of 1, okay? Or 100%, okay? We can find the probability between two values. So let me show you where this comes into play. We see this in college admittance, specifically like this is Harvard, okay? If you have an SAT score that is closer to 1860, that puts you in a specific category and gives you a higher likelihood of getting into Harvard. So this underneath, what is shaded, we call that a density curve. A density curve. And the total percent inside this density curve is 100%, okay? 100%. Now, the closer you get to the tails, the smaller the percentage. Does that make sense? So the percentile of someone who would get a 2200, well, that's not, I don't think that that's recent, but at 1860, that would have a smaller probability and a smaller area than, let's say, a 1500, which is about average, okay? So that's where it comes into play, okay? It comes into play. Now, you might be like, well, Coach, that's confusing. I'm giving you just a snapshot of, hey, this is what a density curve is. It has an area of 1, and it's applied by college admittance, or if we did our height of our class, being able to figure out what's the percentage or the percentile. So if this was height, where would Coach J fall on that spectrum? Third percentile. Thank you, Josh, for reminding me. Okay? That means that if I were to go over here, 0.03 of this would be shaded that's to the left. Got me? Whereas if someone's like 6'6" or something, they might have more or less maybe this shaded in comparison. Okay? You see that? I know there's short jokes going around. I got you. Okay? But does that make sense of where we're going? All right, so that's it. So to help us with this, I'm gonna have you do the following, and I'm gonna explain as we go around. Okay? You're gonna be doing a lot of hands-on things, so I need kind of your focus and help on this. All right? Over on the right side, I'm gonna have 2 different dot plots that you're going to put dots on, and I'll explain that in a second. The ones that will be over here, you'll have 2 more over on this side. Okay? So for instance, we're gonna look at a stopwatch. Okay? So you gotta really understand this. You're gonna do each of these 3 times. Each of these 3 times. So on your phone, you're going to take out your phone, you know the stopwatch, right? And you're going to start it, and you're going to try to stop it on 5 seconds, okay? On 5 seconds. You will round to the nearest hundredths place. So if you got 5.10, got me? Then what you'll do is over here, you're going to put a dot. I haven't finished it yet, but I will by that time. You'll literally go 5.10, and you'll put a dot, one of those dots that I'll give to you, on there. You'll do 3 of those. So everybody will have 3 on each of these. The second thing you're going to do is you're going to roll a dice. So I'm going to have dice out here. You're going to roll the dice, whatever number you got, that's where you'll put that dot. You'll do that 3 times as well. Okay? Remember, for these ones, this is going to be kind of tighter together. Okay? These ones you'll just build on top of itself. Okay? And you'll see how that goes there. Those are those 2. The third one, I haven't gotten to put it up here, but you'll see it. The third one, you're going to, over in this corner behind Tony, okay? If you want to get up, you can kind of look, because we'll get up here in a second. All right? You're going to take a penny, it's kind of weird, okay? And you're going to try to toss the penny to get it to land right here on the green dot. There's like a green dot right here. The distance from that, you're going to take a tape measure, you're going to find that distance, and that distance is what you'll record on that dot plot. Follow me? All right, and then that's it. So you'll have 3 of them. You'll do each of these 3 times. You're going to kind of spread around and make sure that you do those. But each of these will help us in section 2.2a. Cool? You ready?
Ready.
All right, let's go. I'm going to get the dot plots rolling. If you need dots, I'm going to hand them around. I'll actually put them on this table right here. Okay? These dots will be on this table right
3 times.
here.
Each one 3
Each one 3 times. Yep.
Cheater.
And here's the dice too. Here's the dice too. That one's ready, so you can go ahead.
Do we roll 2 dice?
Say,
Roll 2 dice.
yeah. Or hold up. Yeah, you can.
So 2.
You can roll 2 at the same time.
Round to the left.
Nearest hundreds. Yep.
Oh.
Got this. Here's my tape measure. Here's another tape measure. And again, if someone wants to go to the penny side, you can. You'll do it 3 times. Do it 3 times.
We need to write a prediction before we go.
6.
Wait, how do you know that?
No, the prediction is our experiment. Then I'm going to give you the actual what if we did it 100,000 times.
Oh no.
That makes sense.
Hi, Coach Jeff.
Josh,
Can
can
you
you
find a winner to help me?
That's perfect. So yeah, if it's above, then you'll put it above there.
Alright, okay.
Hey, is the stopwatch? Did y'all get that one? How the dot plot's set up?
Yeah.
Yeah, kind of, sort of.
What am I? I got 6, 5,
Wait.
6 on the dice. I'm so good.
Wait, how many times are you doing it?
3 times, just one. You don't have to do 1 basically.
Hey, let's do this. Let's round over there with the pennies. Round to the nearest half inch. Okay. Half inch here. Or yeah, half inch. is perfect.
I got 4.39.
That's scary. That would be all. If you hit exactly 5,
I know.
I should give y'all something. Get like a free 100 or something.
No. 101.
Hey, Claudia's got the closest with 0.01 from 5.
I got 4.99.
I just have the one. I just have the one up to Claudia now.
Oh, okay.
I will.
Oh, you know what?
I spent all my time doing that.
Hey, y'all, do this. Round to the nearest inch over there with the pennies because I don't know if this is gonna. It's gonna be kind of fun.
5.04.
I was 0.4 off.
If it's halfway, then I guess we could put it right in the middle.
Yeah.
What's the dot plot you're working on? Is that the penny plot?
Yeah, this is the penny one right here. So this is pennies distance. Oh my goodness. Is 10 in? Yeah, do that. Yes, redo that. Redo that. We'll see if that goes. Hey, within 10 inches, is that about?
No, no. Wait.
So this is 5?
Yeah, maybe not. Maybe not. Let me redo this. I need to do y'all's, okay?
What
This is
happened?
Fiona's, alright? This one's for Fiona.
Because Fiona was like 27 inches.
29 inches and 3 times.
It'd be that way. It's okay.
It's just how it is, okay? We just, it's just how it goes. It's just
Alright, here we go. This is
One of mine
Fiona's.
was
Let's
like
go by
5,
2s.
One of them was like 19.
Fiona's is still off. Fiona's is still off.
I'll just be
Next one, you trying to roll some dice real quick?
Yeah.
Roll that.
My God.
Hey, bro, I did this on my phone.
Second on the dot? I'm just like right on there.
I roll on point, though. Give me that seat.
Wait.
No, everyone's getting like
Oh,
5.01 and 5.02.
This one, though.
It's all people like on each other basically.
Next time, yeah, you would put it above.
Okay, fine.
See, palm dice, bro.
That's
That's what I was talking about.
You got
I like the trash.
Yeah.
That's where the sides are all.
I started it and I did it well.
That's where I'm getting
Yeah, I
hot.
think it was Jared actually.
That didn't work.
You were like,
I
yeah,
just
why
can't
is
do
it
it.
all
Yeah,
the
see,
way
right
there? Right
That was
now.
partially my fault. I thought it would be further away.
Oh, no.
I guess someone who would get 4.5 would be like,
What the?
See, I know.
I'm gonna roll no dice.
Okay, wait.
I told you she can't roll no dice.
Again, make sure you do it 3
That's not
times and then put it over there.
Can't roll no
3
dice.
times and then put it over there.
So what am I supposed to be doing?
Just roll it.
No, it's 6.
What'd you get there, Rita?
Just 3.
Just one?
Yeah.
Gotcha.
Okay.
2.
Yeah. Attaboy.
All right, we have 46. We have 9 minutes left, so gotta be quick. Gotta be quick.
We'll talk about later.
Hey, we can have multiple people throwing too on those pennies. That's fine.
Oh,
Multiple people. I think I got a couple of tape measures.
I didn't count that. They went well. They look really good. I'm super happy. I scheduled mine for Thursday because I was not ready. I did not know when they were. We did 2 outfits. So we did the drape, the tapping gown, and then 2 outfits. You're supposed to just roll 3 times.
Exactly. Why you're like, come on. Get that off.
You and our data.
See what you did there, skewing.
They didn't send me a little one of these, right? They only gave me
Attaboy. Thing is, I know how to
I can get them done like separately for like this.
I don't know.
No problem. I'll podcast.
Attaboy.
Thank you for telling me,
Okay.
Emily.
Do you have dice? No, I need stickers.
I think they're over there. And there's dice over here too.
Oh wait, okay, I need to get
These are dice in dice.
Oh, okay. Oh my gosh. Oh, these are dice.
I don't think yours. Yeah.
I still have to speed up if I gave this one back.
We'll count it, but you can just put it right here. This one is our penny stock.
Okay.
Which one do I like? Go by. Okay, I'll go with this one. Honestly,
That would be so funny.
So you lose.
Hey, let me do this. Let me get another one. Let me get another one rolling. And that way we can get it quicker.
Dang, I got the highest. I got 2 inches away. I'm so good at this. For the top.
All right, hey y'all, if you want to, you can throw more pennies over on this side. Cool. If you want to.
We try to work on. Oh,
Trying to land
you're
it on
all
the green
good.
dot.
I am.
If you land it on the green dot, I'll give you like.
No, I'll talk to you later.
Okay.
2, 4, and I
Then
got.
you'll measure that. Once you do that, then you'll measure.
It's right there.
Too good. Can you read?
Okay, ready? 1, 2, 3, go.
Yeah.
Yeah, you'll
Ew,
throw 3 times.
awesome.
Over here, my fault.
Yeah. Yeah.
Just a second. What are we supposed to do here? So, that's for the penny toss.
All right, make sure you do 3 of each. 3 of each.
Highest score on penny toss. I got 2 inches, and then I got 3 inches, and then I got 5.
Oh, did you?
I'm the best penny flipper in the class. Don't ask me.
That's impressive. That's something.
Charles, you're bad at penny flipping.
That's what I am. Like, come on. Best round.
Who's actually farther?
Really?
21? 21?
Oh wait, is that centimeters?
Inches. In inches. Should be in inches, y'all. Inches, y'all.
That's 9. Let's go. 21, 18.
Charles, you say 9?
Yes. Oh, dude, I'm the best.
Oh, shit.
Hey, if you're done, here's what I want you to do. I want you to identify. Hey, do this real quick. Everyone look up here real fast. We've got like 5 minutes. If you are done, I want you to go through each of these 3 activities we did, and I want you to predict, based upon what we have, what would the graph look like. Okay? Cool? I'm curious. If you're not right, there's no right or wrong. I'm just curious to
Wait,
see
say that again. We're going to the graph.
what would the graph look like for the 3 activities. So like for the stopwatch, what would the graph be? What would the graph of the roll of dice be?
So take it from a bar graph and put it into like a
So this will be like a histogram.
Yeah.
This would be like a continuous distribution. So would it be skewed left, skewed right, or
okay. Skewed left.
approximately normal? And then same thing over here.
Yeah.
Trump runs into the chair like it's nothing. He goes,
I just remind my need to fall.
oh, alright, is everyone done? Hey, Ryan, are you done? Yvonne, are y'all done? Is anyone still working?
Someone says.
What's the prediction again?
The prediction is what you think will happen.
Okay.
So, like, based upon the graphs you see, what could we assume that, would be the best in terms of shapes wise? Okay.
If it went straight on this, and then it rolled like
1 minute.
All right, let's do this. All right, so you have these three, okay? The first, second, third rule is not necessarily needed. But what I'd like for you to do is this. The prediction is what you think or what we had within our distribution. So if we come over here, you'll notice that it does kind of dip and come back up again, okay? So our prediction is kind of what happened with ours. So ours, if I was to like put this down, we saw that when we had 1, 2, 3, 4, 5, and 6, that within this histogram that we could say that it kind of went up and then what kind of dipped back down a little bit, although they're spaced a little differently, right? You see that? The dots are spaced differently. How could we make that dot plot better? Make sure it's spaced evenly, right? That way we can actually see it, but we'll go with it. Here's this for 2 and 3. For 4, it kind of went up just a hair. For 5, and this is just rough. We're just trying to do a rough sketch here. And then 6 went up quite a bit, okay? Now, what's the actual, if we did this 1,000 times, so this was like a sample size of, we'll say it's approximately 25, 30, okay? What if we did it like thousands of times? What'd you say, Ryan?
The graph is affected.
Oh, change a little bit? That's okay, it's cool. If this did, though, if we did this 1,000 times, 100,000 times, what would we expect this to be? So we just did this a lot. What would be the actual value? What would be the actual times here, right? So this is frequency. Okay? If we actually did this, 2, 3, 4, 5, 6, any thoughts? Wouldn't they be pretty much the same?
Yeah.
Because the probability of rolling a 1 and a 6 are the same, right? Now, you see that this dips here, right? The beauty of statistics, like Vegas sometimes, when they put out things for like gambling, they know they're going to lose money on occasion. But over the course of time, over thousands and thousands and thousands of times, they're going to make money in the long run, right? Same holds true here. The more samples that we have, the more it actually will come out to what it should be. So what will happen is you're going to see that the distribution will be the same whether it's 1 or whether it's 6. Cool? So if you were really trying to draw this, it would be the same across. Okay? All right? What do we call that? Say again? It could be kind of approximately symmetric, right? Approximately normal. I did say that. That was kind of a bad on me because now we're going to move into a different language. You're going to see what approximately normal is. We say it's symmetric, right? Symmetric on either side. This is also a density curve that has an area of what? Of 1. Good. Area of 1. Which means that what's the probability of getting a 1? 100 divided by 6. Right? Hey, we're going to kind of build on this concept. Sound good? Have a phenomenal day. See y'all later.
No, dude. Come on.
Good job, y'all. Ivana, I'm so sorry again. I owe you.
Gianna. At least you didn't call me Ivana.
You're both reminding me.
Johnson.
Not his, well, he has a country accent.
See you. Have a good day.
Let's go, bro. Macroeconomic. Oh, wow.
So there's 20 some tournaments, right?
Or like that's the top. Out of all the people I saw,
Good shit.
Are you a golf fan? Play golf?
I used to and then I broke my arm.
Oh, not that you broke your arm, but that you like golf. I'm so sorry.
This is not.
It's possible that if there's only that many, we could do something different, like
Like I'm.
driving distance. I'm just making something up, okay? Your average driving distance, and then you compare the top. You take the top 50 in money for the year for ranking, world ranking, and maybe you just do like driving distance or something, and then you could compare the top 25 to the next 25. Separate them and see if driving distance has a say so between those that are in the upper echelon versus those that are in the 25 to 50.
Okay, so like
I'm
for
just making.
example, this isn't what the data piece, but I just found it. So I would do like, or could I do like total